Alright, so in this short video we are going to go over a brief summary of what the 5-number summary is, and then we are going to construct both cases of box and whisker plots and the modified box and whisker plot. Alright, so the 5-number summary is going to be the list of these 5 important points on a given data set. That is, the smallest of them, the largest of them, the one that lies exactly in the middle of the set, that is the second quartile, or also we call it the median, and we look for the first quartile, which is the 25th percentile, and the third quartile, which is the 75th percentile. Essentially, box and whisker plots are going to have this shape. Okay, just briefly speaking, it's going to look, I'm just going to draw a very rough graph. Here we're going to have the minimum. Here we're going to have the maximum. And somewhere, I don't know, maybe here we're going to have the median, which is Q2. We're going to have over here Q1, which is the 25th percentile. And we're going to have over here the position of Q3, which is the 75th percentile. All right. Now we need to define another piece of information called the interquartile range. That is this quantity that we have here, which is the difference between Q1 and Q3. Between Q3 and Q1, that is the length called IQR, which is the interquartile range, because it's the data that lies in between the quartiles, the 25th quartile and the 75th quartile. Doing this by hand would be kind of tedious, so I'm going to show you how to do this in the graphing calculator. All right, so I'm going to show you on the next page. We have the data set right here. Okay, so I have this set of data in which that I have already put in the graphing calculator. All right, so first of all, we're going to look at this example and calculations for IQR shortly, the lower cutoff and upper cutoff for outliers. I'm going to explain that briefly after we do the very first case of this box and whisker plot. All right, so let's see. Have some light here so we can see the calculator, what we're doing. All right, so I believe I already entered the data. It's right there already. First of all, most of the times, more often than not, you might need to order data from smaller to large, and that's very common. That's what we do precisely when we find the median, because that's when we look for the element that lies exactly in the middle if the number of elements in the set is odd. Otherwise, we look, if it's even, we'll find the average of the two in the middle. So in this case, let me show you first how to order this data set. So in this case, we're going to go sort A, and we're going to enter manually second one, which is for L1. That is the list that we want to sort, and it says it's done. Now let me show you the list, and now you will see all the numbers arranged from smaller to larger. Okay, so but again, you don't have to write them by hand, because the summary that we are about to do is going to show us what number is exactly the median. Okay, so let me quit. So let me clear over here. So we're gonna go this time. We're gonna go to stat plot. However, before doing stat plot, click y equals and be sure that you do not have any other function so it doesn't interfere. Let's say you have a trigonometric function, an exponential, a parabola or something. So be sure everything here is empty. Okay, I'm gonna quit again. I'm gonna press again the y equals, however, with the second function. So second, that way I can reach the stat plot because there's a few stat plots in here. Okay, so let's see. I'm gonna choose the first one. Be sure it's on. Click enter, and then be sure it's also on here. Now, when it comes to type, okay, so for type, there you will see a few different graphs. I'm gonna do this one right here. There's another that looks like box plot. However, this box plot, if you notice, it has two little dots in here. We're gonna do that second. This is gonna be for the modified box plot, and this is going to be for the box plot that we are going to do now. Okay, so I'm gonna choose this one. And if you have a color preference, you have blue, red, black, magenta. I'm going to do magenta this time so we get a good contrast. All right, now notice we stored all the data in our L1. For the freak, don't worry about it. You can just ignore. In fact, you can clear it if you want. Okay, so now you are going to hit graph so we can see the graph of this box plot. All right. Okay, so notice in this case you are going to see a horizontal line at 1, 2, 3, 4, 5, 6-ish. Of course, we don't have any y equals 6-ish because we know for sure we clear all the functions in the y equal command. So the thing is, this is indeed the box plot. However, we need to play with the zoom in order to see the entire box and whisker plot. All right, so in order to get that done, so you don't have to zoom once and another and another, and so you can do that in one click zoom and scroll down to zoom stat, and that is your box and whisker plot, in which I'm going to navigate, I'm going to trace. So if you were looking at other graphs, what you would do is navigate through with the arrows, right? But that's just going to move your cursor, your star right here, anywhere in the Cartesian plane, and you want to know the specific values, the mean, the max, Q1, the median, and Q3. In that case, click the trace button. Once you click the trace button, you may now navigate through the 5 parts of the box plot: the minimum, the first quartile, the second quartile, aka the median, the third quartile, and the maximum. All right, and that is how we do a box and whisker plot. All right, so that is the type of plot that we use to answer the question, write down the five number summary of a given data set. So we are going to use this box and whisker plot and some other formulas like the IQR. We're going to use the IQR to determine if we have outliers, that is, values that are not very common. Okay, so that's what we call outliers. So, but for that, first of all, let's calculate the IQR. I have it by hand here. However, let me verify that. Q3, which is 56.5, it's right there. 56.5 minus 38.5, which is right here. Take the difference between those numbers, and the difference is 18. All right. So we are going to calculate the first lower cutoff. So for the first lower cutoff, have the calculations here. The formula is for the lower Q1 minus 1.5 times the value of IQR, which is 38, 0.5 minus 1.5 times 18, and the lower cutoff is 11.5. That means that everything below 11.5 will be an outlier. Okay, would be an unusual value. For the upper cutoff, instead of having Q1, we refer to Q3, but we add 1.5 IQR. So 56.5 plus 1.5 times 18, we get 83.5. So in this case, everything that lies above 83.5 would be an unusual value, aka an outlier. Now, how can we display those outliers, and how do we display those outliers that are not, that are in our graphing calculator? So in this case, let me quit first. I'm gonna go again to second stat plot. Okay, and now I'm going to select the other graph, the previous one. Those little stars are going to be the outliers. So I'm going to go the same way, and for the marks I'm just going to use the plus sign, I guess, and I'm going to graph. I'm not going to hit graph. Alright, okay, so let's look at this graph. It looks a little bit different. Let me zoom stat. So that's what we have for this graph. Let me trace. Let me click on trace. Click on trace, so we can navigate through the 5 number summary. The median, which again is 43.5, 38.5, which is Q1, and it's 56.5, which is Q3. The maximum in this case, well, we have a 63. All right. So this is not the maximum. Okay. And then over here we have the other endpoint, which is 25. That is not the minimum, right? On the previous graph, if we compare with the previous graph, let me compare. Plot graph. The minimum is -13 and the maximum is 117. But what's different in the other graph? Let's find out. So the values that are, first of all, let me show you the value by the graph that I did by hand. Okay, so this is the graph that I did by hand. Okay, so we are going to have the 2563. Okay, and this 25 is the minimum value that is not an outlier, and 63 is the maximum value in the dataset that is not an outlier, because here we have this lower cutoff and upper cutoff. So everything past these vertical lines are going to be unusual values, aka outliers, and which is what we're going to have in our graphing calculator. Let me graph. So let me click on trace, same numbers. So -13, which is coincident with this -13 here, and then the next one, 25, which is what we have here. Okay, let me put the paper here. That's 25, and then we're going to reach the first quartile, which is 38.5. I didn't write that down, but it is, trust me, that's what it is. That's Q1, and that's Q3, and then Q2, or the median. In this case, the median 43.5. Same numbers. Numbers in the box are the same except the ones in the whiskers here, which in this case, for the modified version, we are going to have the minimum and maximum that are not outliers. And now we have other outliers, which is 108 and 117. Okay, and this is how we do a box and whisker plot using the graphing calculator. So depending on what you're being asked to do, in some cases, what if you're given a data set, and they ask you, well, what is the minimum value that is not there is not an outlier. In this case, you might want to use a modified box and whisker plot, because this is going to be the minimum that is not an outlier, not the absolute minimum of the data, or otherwise the maximum value that is not I mean that is not an outlier. Or maybe another question could be, how many outliers are there in the set? Well, in this case, it's useful to use a graph, a modified box and whisker plot, so you can count them: 1, 2, 3. So there are 3 outliers, 1 below and 2 above. Doesn't matter just how many. Okay. Otherwise, again, if you just want to know the 5-number summary, just use the other plot, the one that doesn't have the outliers. Okay, this is the end, and I hope this is useful.